Hello friends, in this discussion we're going to be looking at power electronics and we are localizing our discussion on DC-DC choppers. So a guiding question says a chopper circuit which operates in time ratio mode at a frequency of 2 kHz with a 460 volts supply. If the load voltage is 350 volts, calculate the conduction period of the thyristor during each cycle. If the pulse width is halved, for constant frequency, find the new output. So we are looking at a DC converter, which is called a chopper. And a chopper that we're talking about here chops the 460 volts supply to a 350 volt supply. So this is a step down chopper. So a step down chopper will have a particular formula for calculating the output voltage, and a step up chopper has also a given formula. So now we are told that we are to calculate the conduction period of the thyristor. But maybe first of all, let me talk briefly about the TRC. Time ratio control mode refers to type of control of a DC chopper that we control the output voltage by varying the duty cycle of the chopper, and has two different types of TRC modes, and one is constant frequency time ratio control mode, and the other one is variable frequency time ratio control. So in our next videos, we shall be talking about that TRC operation for a DC chopper circuit. So let's right away see how we can solve this problem. So we have from V naught, which is the output, the DC output of this chopper circuit, equaling to Vs times alpha, whereby alpha is the duty cycle. So alpha is the duty cycle, and we already know that this duty cycle is also equal to the on time of the circuit, or the on time of the DC chopper, divided by the total time of the cycle, which is the period. So for that matter, we can just bring this in here so that we have V naught equal to T naught divided by T times Vs. But 1 out of T itself is what we call 1 out of T is the frequency of the cycle. So V naught will therefore equal to T naught, T on times frequency times Vs. But do we know the frequency? Yes, the frequency is 2 kHz. So for that matter, therefore, T on, or the time, the on time, or the conduction time or conduction period for this thyristor is going to be V naught, which is 350. We divide it by 460. So this is 460. Of course, we divide it by, again, frequency, which is 2 kHz. So 2 times 10 to the power 3. So what does this give us? So the conduction period, T on, is giving us 0.38 milliseconds. So that is the conduction period for this thyristor in each cycle. So next we are told that if the pulse width is halved for constant frequency, so part 2, if the pulse width is halved for constant frequency, what does that mean? That means T on, or the conduction period for this cycle, is going to be T on. Of course, the new one is going to be T on divided by 2. So this is going to be 0.38 milliseconds divided by 2. And this is 0.19 milliseconds. So what does that mean? We are going to see what is going to happen to the output voltage. So we know the output voltage is defined by P on times F times Vs. We know Vs as 460, so we multiply by 2 times 10 power 3, we multiply by 0.19 times 10 power negative 3, because milliseconds is exponent negative 3. So 0.19 exponent negative 3, we're multiplying it by 2 exponent 3 multiplied by 460, and this is what we are getting. So our V naught or V output is going to be 174.8 volts. So we can see what happens if we have the pulse width for this cycle keeping frequency constant. The voltage is further going to be chopped down to 174.8 volts. Thank you.